Hopefully we are all live. Someone can just give me an okay just to let me know you can hear me and see me all right before we get going. Lovely. Hopefully there's some people out there listening. So for those of you who obviously watched this last week, welcome back. For those of you who are new to this stream series, hi, I'm Alex. I'm from Norfolk originally, so technically I guess I am a Norfolk developer, but living and working in Suffolk at the moment for a company called Inawisdom. Inawisdom are a kind of AI and data consultancy business, very, very much focused on the cloud and AWS. Just before we get going, there's a couple of things I wanted to speak about. The first one is that if you are interested in this kind of thing, and you are currently working in AWS and are looking for a new challenge, then we are hiring across a number of areas at the moment. We are always busy, always growing. I joined them kind of 8 or 9 months ago, and there's probably 50% upturn in headcount already. So yeah, growing very, very quickly. But yeah, vacancies can all be seen at www.inawisdom.com/careers. And if you have a look through there and see something you like and reach out, then our friendly in-house recruiter Greg will get back to you and set up some chats. And secondly, just a little bit of a personal plug. I do write about AWS sort of semi-regularly, just at myname.co.uk, so alexkearns.co.uk. There's all sorts I kind of tend to write about. It is primarily focused on AWS, and I brought out a new blog post yesterday all around kind of security, cyber attacks, and how AWS can help you to protect your application from this when you're working in the cloud. If you are interested in finding more out about this kind of area, I'll pop the link to this in the chat on YouTube. And also I'm speaking at the end of March at the OWASP Suffolk meetup, and that will be a very AWS heavy security talk, if you are interested in that sort of thing. And I will dig the link out for that at the end of the stream and post it in the chat as well. That's all of the pre-ramble I wanted to talk about out of the way. So let's get going. I'll kind of give a little bit of a quick overview in terms of what we did last week, just for those of you who haven't, or who weren't here last week and want to know where we are. So we're building an application to track the different variables that go into making an espresso at home. So when you make an espresso coffee, you can change things like the temperature of the water you're brewing with, how fine or coarse you grind your coffee beans. Of course, the beans themselves can change, among other things. And I've found that, having recently kind of got into this at home, that trying to get consistency between kind of coffees over time is a little bit an art. So yeah, I thought it would be really cool to build an app, or web application in AWS to monitor these things for us, to allow us to record them and to be able to see kind of over time which ones have tasted the best, which ones haven't tasted the best, And in theory, it means that the next time you buy that particular coffee bean, you know straight away how to kind of dial your machine into the correct settings for it. So in terms of where we got to last week, we had started looking at AWS SAM, which is the serverless application model, and we built a kind of really simple template. And this template provisioned an API and a Lambda function. Kind of what we got to with that was we got to the point where we could run or post a request or get a request rather from this endpoint, and we'd get back some kind of dummy data. So at the moment we haven't got any data persistence. It's just returning some fake data from inside this Lambda function. So what we want to do today, I think, as always with these streams, you kind of have a plan in your head for what you want to do, and then it never really goes how you expect. But essentially what I want to do today is try and get some data persistence, I think, into... Can you excuse me 1 second? I think my cat's throwing up. And there's your proof that this is really live and isn't pre-recorded. So we got to the point where we got these kind of dummy data being returned, and we needed to start thinking about how we want to persist data, and obviously return that persisted data later on. So kind of the first thing I want to think about tonight is probably how we're going to store data, where we're going to store it, and kind of to do that I want to kind of introduce a service called Dynamodb. So Dynamodb, for those of you who have not heard of it before, it's been around for, I think it's just turned 10 in terms of AWS services, and essentially what it is, it's kind of it started its life as a key value store in AWS, and since then it's really kind of been adapted, expanded upon, and now you can do some really kind of quite clever things with it. So ultimately it is still kind of key based, in that when you sort of create a table, you have a partition key and a sort key. These two keys are determining what you can query on. So the one thing with Dynamodb is you need to think about your access patterns kind of up front, because you can't kind of change those things later. You don't necessarily want to think of it as a relational database, because it isn't. It does fall very much into that NoSQL camp of databases, and when you try and build data models for it, you do need to keep that in mind. So there is an app that AWS have produced called Nosql Workbench, and this application, which I may have already, may not do, this application allows you to kind of model out the data and visualize those access patterns before you go ahead and build the table. And then if you connect it up to your AWS account, it can then also automatically kind of push changes if you do need to make changes. So let's run this and have a look at it. So we can use the Dynamodb version of Nosql Workbench here, and see if we can zoom in. So what we want to do to start with, we want to think about how we can access this data, and what patterns we need to think about in order for our application to make those requests. So let's call this coffee. So there's this concept within Dynamodb called single table design, which was kind of pioneered by a guy who used to work at AWS and he's now moved on to MongoDB. But there's loads of resources out there now about this concept of single table design in Dynamodb. And essentially what it means is you haven't got to create kind of multiple tables like you would in a relational database and do things like joins, or because joins aren't possible in Dynamodb because it's not relational, you haven't got to do things like, if you had, for example, a customers and an orders table, two separate tables, you wouldn't have to do one request to customers and then one request to orders. You'd be able to get it all from the one table. So let's just call this one single table. All I'm going to use this workbench for is the modeling. I'm not going to use it for anything else. We're going to model it here, and then we're going to build the table definition itself in CloudFormation, where we built the same for our functions. So I'm going to call our partition key just PK and our sort key SK for partition key and sort key, just because they're going to contain different pieces of data depending on what type of item is in there, and this will make a bit more sense in a moment. But where I mentioned before about the access patterns, Nosql Workbench has this feature in it called facets, and with this facet you can say, for example, a facet might be coffee beans, and then the partition key might be bean name, and then sort key could be I don't know, strength or something, for example. And then what we'll find is that when we start to visualize our data, we can start to look at these access patterns and it'll make a bit more sense in our head. So if we add this kind of single table design here with just essentially at the moment all it is two keys really generically named, but we can start to add some data into this. So let's start off, because we've started working with our coffee bean as our resource in the REST API for listing, getting, updating, creating and deleting. So let's begin by thinking about that. So you want a partition key to be not necessarily unique, but your primary key, which is either this on its own or a combination of these two, does have to be unique. So I couldn't have, say, coffee bean 1 with a strength of 5, and then another row that says coffee bean 1 strength 5. But what I can do is I could have coffee bean 1 5, coffee bean 2 5. That would be fine. So let's what did we call them in here? I think we called this one Brazil was our name of our coffee bean. So we need to kind of have a think about how we want to model this data, because there's a few things that we're going to want to include in this data store down the line. So it's going to be things like not just the coffee bean, but it's going to be things like the brew, for example. So like the actual instance of us making a coffee. So let's call this like brew 1. That can be our, we'll have a unique identifier I think in here. And then what's quite kind of commonly done is people would use you'd use this sort key to kind of identify almost what type of item this is. So we might say this could be maybe our sort key could actually be, rather than strength, it could be used for identifying the type of the item. So our type here could be bean, and this one could be brew. So if we imagine that this is actually a kind of a UUID that we generate, what you always need to keep in mind is that we need to be able to reference back to this. So it does sometimes make sense to have a kind of readable name in there, but for things like the coffee brews themselves, it doesn't really matter too much, because when they're listed out, we'll show the information we need to show. When they are being updated or put for the first time, we can generate this or retrieve it from a list. So it's all quite straightforward, I think. And just thinking about it, so the two, I think these probably are the two main models we're going to be looking at in this application. One being the coffee bean, and one being the act of making the coffee from that bean. So if we go with this here, what could we do? This is where I mean it's really important to think about these access patterns up front, because we could even make this even simpler by saying this partition key is the name of our coffee bean, for example. So this sort key can be what type it is. So let's say the type is going to be bean. There's no syntax around this. I'm just doing something so we can so that we can actually remember that this is the bean. And then what we could always do is we could always then, because logically a brew for a particular bean is related to that bean, so we could then say this second row is going to be a date time, for example. So let's go for today. Let's say I've just had a coffee. And what we'll see later is when you're querying for things, you can actually, on the sort key, do things like look for prefixes. So we could say, I want to see all the brews for this particular bean. So I'd say, give me all the items in Dynamodb Table where partition key is Brazil and sort key is brew. So what we can do then is we could even actually rename this to something like, let's call that metadata, because then we can start to include in this item some of the other attributes that belong to this particular type of coffee bean. So what we can do from here is we can start to add some other attributes. So we know that for a coffee bean itself, we need to know things like perhaps the strength. That strength is probably going to be a number. We need to know maybe the roaster, so which company has roasted it. What else have we said? And then maybe we could finish off that bit with saying let's put something like tasting notes or something, so that you could look at your collection of beans and add information about how it should taste, and then maybe we could reuse this same attribute for the brews to say, for example, I tried this coffee, I made this from this bean and found that I could taste loads of chocolate or loads of fruit or whatever it needs to be. So these three probably add everything we need for the coffee bean itself. And in terms of the brewing process, we're going to have things like the grind size, so that's going to be a number. We're going to have things like the water temperature, which is going to be a number. What else do we say? We've got things like the dose, which is how much coffee you're putting in grams. You've got the yield, which is how much coffee you're getting out in grams, done by measuring how much espresso. And then let's have one that's say, extraction time, and that's how long the coffee has taken to get to or get from those to this yield. So for example, if you put 18 grams of coffee in, then most of the time, as an average, you want to get double that out. So you'd want to get out, when your coffee has been through the machine, you'd want to get out 36 grams of espresso over about 25 to 30 seconds. So by recording a few different things here, it then gives opportunities for all sorts. We can look at graphs, we can look at, with enough data, you could even look at machine learning, and you could say, I've made 100 coffees with this particular bean. These are my ratings. These are the variables. Predict what I would need to do to get a good coffee. So there's lots you can do with that. Let's just update this. So we've got no, let's get rid of that, because I think it's going to get confusing. So now we've added all of these extra attributes to our kind of model for for what we're thinking about with the data, we can go back to our visualizer tab and add some more data in here. So this time, also we've got all of these different attributes. We're only going to use some of them for different types of item. So what we could do is we could say, okay, so that coffee is 5 in strength. Maybe the coffee comes from, say, Stranger's coffee. Say it's quite chocolatey. But all of these next ones here all relate to a particular brew, not to the actual bean itself. So this is where we could perhaps say, okay, I used number 7 on my machine. The temperature was, say, 95 Celsius. I put 18 grams in. I got 36 grams out, and it took 25 seconds. So we start to kind of build up this collection of items, and what you then see is when you look at this aggregate view, you can see these what's known as item collections. Because they're all grouped by the same partition key, we could query this and say anything relating to this particular coffee bean, return in one query, and with that we'd get the information about the bean, we'd get all of the information about the brews that you've made with it, all this kind of fun stuff. And you could kind of expand this out later to include things like if you had 2 or 3 different coffee machines and you wanted to record different processes for different ones, because you might find that number 7 on this machine is the number 5 on a different machine. So you could we could build something like that in as well on this same kind of model. So the second thing we probably want to, do we think about that? No, not yet. Right, so let's have a think about this now. So we've now got all of this. We kind of got a good idea of our structure of our table. But the good thing about DynamoDB is, unless you're using a attribute in your key, so in our case the primary key is partition key and sort key, so PK and SK, or you're using it in a index, which we probably won't come on to today, but we will do at some point in the next couple of weeks. You haven't got to define it up front. You can just put an item to DynamoDB with more information, and what that means, it means that you can manage things like schema changes from your application rather than having to manage updating a database schema as well. So an example I might give would be, let's imagine that we've built this application, we're 6 months down the line, and we now want to add an additional piece of information to the metadata for a coffee bean. So what we could say is, let's add an additional piece of information here by changing our source code in our application to just start writing an extra attribute to the items called roast level or something, whether it's light, medium, or dark roast. So we can do that without even touching DynamoDB. We can just start writing new attributes and they'll be recorded. And then all you'd need to do in your application is you just need to make sure that you're kind of gracefully handling any items that are kind of older that won't have the new information. Whereas with something like a MySQL database, you would have to run your kind of migrations. You'd have to make sure that you run your migrations kind of before you release your source code, so you don't end up trying to write information to a column that doesn't exist. So yeah, this does make life easier kind of once you've got your head around this idea of it just being kind of key value, but the patterns enabling it to be very, very powerful. So enough kind of talking about access patterns. Let's actually go and try and build this table, and then start writing to it, because that's probably going to be the most important thing. I think that the plan for what I want to do for the rest of these streams, so we've got to see this week and then 2, maybe 3 more, is to get to a point where we've got the API writing and getting data, probably this week would be nice, and then building using kind of Tailwind, a really simple front end. May get onto kind of authentication, maybe not, we'll see how we're doing for time, but that would be really nice as well. And what I've kind of got in my mind as being a real stretch, but might be quite cool to play with, is there's an AWS service called Recognition, which is a machine learning powered service for image recognition. So I kind of thought it'd be really, really cool if you could take a picture or upload a picture to this web app from your phone, and this picture was of, say, the front of your bag of coffee, and it would automatically pick out from that picture the name of the coffee and perhaps some tasting notes if they're on the front as well. But we'll see how we're doing for time on that one, because that might take a little bit longer. So then, yeah, let's start looking at this this Dynamodb table to build in CloudFormation. What we'll do first of all, actually, is we will just redeploy this back to the redeploy this back to AWS. Obviously I took it down last week to stop my build going crazy, but we can redeploy this now. So we can just do sam build and sam deploy. I've already set up my credentials and everything, so that I haven't got to go ahead and share them with everybody. So let's just wait for this to happen. These won't take too long to deploy, and then once we've done that first deploy of the evening, then it will be quicker each time, because we're only doing the incremental deployments. But you can see, of course, all of these kind of generated resources for us that the serverless application model creates kind of on our behalf. So we just define the kind of serverless function, and we can define things like this and say, yeah, let's set up these events to trigger this function, and then the serverless application model goes away and creates all the permissions and all the stages for the API and everything that we need, kind of magically, which is nice. But you can still, because it is just CloudFormation underneath, you can do all of it completely manually if you really wanted to. So yeah, let's look at the Dynamodb table first. So let's call it something like this, and it's going to be of type AWS Dynamodb table. So the first thing you have to define is the key schema. I might have to look at the documentation for this because I don't have to write this very often. But I think it's like this. So we'll pull up that one PK and then our type. So the word partition key or words partition key are synonymous with a hash key type, because that's how it stores them on the actual database. So you have hash, and then you have a range key, which is your sort key. So let's just pull up the documentation for this before we get too far in. Key schema, attribute name and key type. I was close. And then you also have to define the attribute schema, or attribute definition, is it called? Attribute definitions. And all we have to declare in here is the ones that we've declared in this key schema here, just so Dynamodb knows what type of column or attribute it will be. So both of these will be strings. Is there anything else that's required on here? I don't. What I will do is I'm going to set the billing mode on this table to be pay per request. So you can kind of use it in a pay-as-you-go manner, where you do literally pay per request the table, or you can provision capacity and then pay all the time for it. Generally, the best route to take is, if you're releasing something into production, then yes, it is a cat, you can hear Alex. Then you might want to use pay per request for the first kind of couple of weeks while it's while you can get a good baseline of how much capacity you need, and then you can provision some capacity so that you can so that you can save some money. I don't think any of the rest of this stuff we need to worry too much about. No. So we've got this Dynamodb table being created here. What I'm also going to do is I'm also going to get rid of this models bit from the API gateway that we looked at last time. I had a read up of what it did, and I think I would prefer to focus more on kind of the code for actually getting things working and doing some cool things, rather than diving too deeply into that stuff. So let's just try and deploy this now with this new table, and we can then have a look and see what's going on in the console. This looks like it's almost done. There we go. So if we now look in the DynamoDB console, we should now see a table here. So it's created a name for us because we haven't explicitly given the table a name, which is fine. And then we can see it's got our partition key and our sort key that we've defined. Everything is in this kind of on-demand mode, which is the pay-per request thing I talked about. And then there's also, quite recently, DynamoDB has brought in this concept of infrequent access tables. For the most part, standard is where you want to be, but unless it is truly like once in a blue moon type infrequent access, normally the standard type works out cheaper. So we've got this table now. We're not really doing anything with it. So let's change that. Let's start writing some data, shall we? From our API. Because as soon as we start writing data, we can start returning data. So what we need to do is we need to make sure that our Lambda function has got permission to write to this table and to get from this table and all of the usual bits. So we can add onto this serverless function resource here a property called policies, and that policies you can add in statements, and these statements are regular AWS IAM policy statements. So what we can do is we can do this first one here, which is allow access to DynamoDB, and then the effect is going to be allow. The action, so we'll have a number of things. So these all pretty much map one-to-one to AWS API calls. So it normally is a good place to start when you're looking at these statements here. So we know we're going to want to do things like put an item. We're going to want to definitely query. That's probably all we need to worry about for the moment. And then we need to set up to say what resource are we going to be allowing access to in this case. So when we look at the DynamoDB table here, in the documentation for CloudFormation, you can see there's these return values. So we can use this intrinsic function, they're known as, to get the ARN of that table, and that ARN is what needs to be passed into this resource property down here. So we can do something like this. So we can say get the attribute from this resource, and then the attribute we're going to get is this ARN bit on the end. So what we'll find now is that when we deploy this, it will add to the role that is created for this function this particular policy statement, which is what we want to make sure that we can write things to it. And the second thing we want to do with this kind of intrinsic functions and referencing things is we need to know what the name of that table is inside our Lambda function. So we can pass as a environment variable to that function. We can say do this reference function here. So the reference one returns the resource name, so it will return the DynamoDB table name, which is what we need when we're using the Python SDK to query this table here. So we're kind of good on that front there. So we're now sort of starting to get to the point where we can probably start writing some data. We've added the policy to give it access. We've given the Lambda function the information it needs to write that code. So let's create a new method in here, and it's going to be for the post type, and it's going to go to this coffee bean endpoint here, and let's call it. So I think if we have a look at the documentation for the Lambda power tools, we are using this, where are we, API bit here. So we just need to find out how we are going to get the contents of the event in that, or contents of that request. Where are we? App dot current event. Okay, cool. So what we can actually do then is we can just take from this, it gets app from this app that we define up here, which is our resolver for the API. Remember this resolver is going to look at this, it's going to use these decorators on the functions, and it's going to get to the right method based on that. So we're going to add this coffee bean here. So when we do post to this endpoint, it's going to call this method. We're going to use this current event.json body to automatically deserialize our JSON payload, and then we can kind of pull data out from that. So I haven't kind of thought about adding any sort of validation or anything in here. Naturally, you would want to in production to make sure that the length of things is correct, and that the types of data coming in are correct, and whether it's unique, etc. So, but what I'm going to do here instead is I'm going to just do something a little bit more simple instead, and go for building up a dictionary of the data we definitely want to get. So we're not going to collect any data that is additionally passed to this endpoint, and we'll set some defaults in there as well. So if it isn't passed, it will choose a sensible default for us. The only thing we know we do need is we know that we do need the name of the coffee bean. So what we can do straight away is we can say if let's call it name, shall we? If the name isn't in the payload, then again there's this handy helper in here somewhere where we can raise a bad request exception. So let's import all of those, because we're going to want some of them for sure. Let's keep those two for now. So what we can do is we can say, yeah, if the name's not in there, we'll raise that exception with something like name not included in request. So then in this kind of data to add dictionary, I want to define it as it will be put into DynamoDB. So we'll go for the PK, which is our partition key, or the name of our partition key is going to be the JSON payload name. We know that because we're adding a bean to our kind of data store, it's always going to be this metadata one. That's because that's what we're adding here. So let's call that metadata. And then, so we've got strength, roaster, and tasting notes. So let's go for strength. So it's good JSON payload. And rather than referencing it like this, which is going to throw an error if that doesn't exist, I'm going to do it like this instead. So I'm going to do .get strength, and if it's not there, I'm going to use probably just a null value, because yeah, it's something that you don't necessarily want to default it to weak, strong, in the middle or anything. You just don't want to set the value. So we've got strength, we've got the roaster, and we've got the tasting notes as well. If we're thinking of this from a client perspective, it's probably going to be more like lowercase, because it'll be coming in sort of standard JSON format. So let's just update that. So we've got our kind of dictionary of what we're expecting to add into DynamoDB. So then we need to actually add, we need to actually add it into Dynamo. So we're going to start storing some data. So what we're going to do first of all is we need to import the Python SDK. That's called Boto3. It's bundled in with Lambda, so you haven't got to kind of include it in your like requirements txt or anything like that. And then what we're going to do is we're going to specify it kind of outside of the method here. And the reason for that is when Lambda kind of invokes, when it invokes a function, anything outside of your handler can be cached. So obviously these methods and stuff here won't be cached, but the kind of values we set up here can be. And that means that it can be quite useful because it means you haven't got to keep instantiating these objects every single time. With little things, it doesn't make too much of a difference, but if you were doing something like loading in a big reference file or something, then actually you could save quite considerable time inside your Lambda by loading it in outside of your handler. So I've got into the habit now of doing it like this. So I'm going to use this here. So do DynamoDB, and then the table is going to be dynamodb.table, and we're going to get that environment variable that we defined here called Dynamodb Table and use that as a value here. So I just need to import that other dependency there. So this should now give us a client to work with that we can then use this to put data to our table. So what I can then do is I can then go from this and I can say table dot, I think it's per item, and then item can be data to add. And then if it's all successful, we will return, let's say, let's return a message to say maybe something like this. So it'll return return an object with key of message, and the message itself will be whatever we've named our particular coffee bean is added. So let's let's deploy this and see what happens. There's only one way to see if this is going to work, isn't there? I'm also going to change my Python version whilst this is running, just because it's throwing up all sorts of errors at me. How's that doing? Need some hold music to listen to whilst we're waiting for deployments. There we go. Cool. So let's run this. Send a request to the endpoint, and let's see what happens. We might get an error. We might not. So we are gonna, first of all, let's set that to post, make sure that was what we said. Yep. There we go. And I'm gonna send nothing to that endpoint to start with, because I want to make sure this validation's working. So let's post to that, and okay, so we've got a error that we haven't raised. So this will be a good lesson in debugging AWS, which is half of AWS. So CloudWatch is where Lambda logs everything to. So we can go into here, we can look at the log groups, and which one of these is it? No, that was last week. Let's get rid of that, shall we? Just so we don't keep getting confused. That one. There we go. JSON object must be string, bytes, or byte array, not none type. Okay, so I think it's it needs something, even if it's just that. Cool, there we go. So it's, yeah, obviously it's throwing an error to start with, say name isn't included. So if we then said, let's include a name, and let's use that Brazil one as an example, shall we? Cool. So if we've got a success message, hopefully that means that we are also, here we go. So it's added in here our bean called Brazil, our metadata, and then null for everything else. So that bit has worked. So let's try adding in another one. Strength was going to be a number. In fact, let's find one that's actually representative, shall we? That sounds interesting. Let's go for that. I need some more coffee, so this will kill two birds with one stone. So we've got strangers, coffee. It's going to be called that. These are tasting notes, which sounds interesting. And let's imagine our scale is like up to 5. So let's generally you'd find with a kind of house blend. If it's something they serve in the cafe, they tend to be on the average side rather than too strong. So let's try that. Cool. So it's added another one there, except this time we've hopefully got, yeah, there we go. We've got an actual coffee in there, like that. So let's just fill in these other ones. Let's go for the roaster. And that's quite a strong one. And it's quite chocolatey, unless you mess it up like I did this morning, and then it tastes like sour sweets. So yeah, we've now got 2 coffees in there, which is great. Obviously one's going through the API, one we did by hand, but yeah, we've got data in our database, which is a really nice place to get to. So what I want to do next, I think, is let's do the list coffee beans one, shall we? Because we can then query the database. We can get back all the beans, and hopefully get a nice response from that. So what we want to do is we want to do this response here. So let's do table.query. So the way this works is we specify an expression to say what the query expression should be for those keys. So we can say, actually we need to do scan, do we? Yeah. So there's a difference. Dynamo has a distinction between querying and scanning. So scanning will go through the entire table, whereas querying you have to specify your keys. But scanning you can then do a filter. So you could say our filter expression could be that the sort key equals, let's do this, and then I think as expression values you then specify in here and say we want our sort key to be metadata. So this kind of this allows us to get everything from the table. The downside you've got of this is that it's not just going to pull back in terms of the operation. It will pull back everything and then filter it. So you end up consuming a lot of data, and you pay for the consumption of that data, even though you only want kind of some of it. So what we really want to do is just run a query to explicitly target things that have got this kind of metadata here. So what I think we should do is we can actually talk about this idea of indexes now in DynamoDB, because this will be really useful. So what I want to do at this point is in our table, I'm going to add a secondary index. I'm going to call this a global secondary index on the sort key. So essentially what we're doing here is we're flipping things around. So we're actually saying when querying this particular index, our sort key becomes our partition key. So what you'll then notice is when we go back to this visualizer and we view it this way round, I can now query and say, give me all the items that start with this metadata thing here. So what that means is then we only pull back from DynamoDB and we only pay for retrieving the items that we're actually going to return to the API consumer. So the one consideration we might need to make with this is what would happen if we had a different type. So for example, if we wanted to add a type of item where we wanted to include more information about the roaster. So say we wanted to include where they were located or a bit of a description, we might want to actually have in here, our partition key could be stranger's coffee, and our sort key would be metadata so that we can distinguish that we've got some data about it. The problem you've then got is that you can't distinguish necessarily what the difference between bean metadata and a roaster metadata is. So if we do this route, I think what would be worth doing is we'll change this so that when we write into DynamoDB, we do something like that instead, because then we can query and say, give me all the items that match this bean metadata type thing here, which I think is going to be a useful thing to have. So let's make that change in here first, and then we'll update it by hand in here to save us deleting and sending new requests in. And finally, we want to set up this secondary index in our definition for our table. So if we look at the DynamoDB table documentation page on the AWS site, we can then see that in here there's this property called global secondary indexes. So let's add that in, and we can then define what those indexes are going to be. So we're going to have a list of this type, and it's going to have index name. So let's call this global secondary index SK for sort key. This concept of projection, so you can configure an index to include everything, so all of the attributes on all the items in that index. You can configure it to include just the keys, and you can configure it to include specific things as well. But for this, I'm going to say everything, and then we can do this key schema thing again, which will match up with kind of what we're doing here. The difference will be this time our sort key is actually going to be our of type hash, which will be the partition key. So like I said, we're essentially flipping, when we're using this index, we're flipping the keys around. So you've got wherever it went, yeah, this, our primary key just becomes the values of our sort key. So it's using these indexes to implement alternative access patterns, and that's why it's useful to not always necessarily name these things really specifically, rather to go for something quite generic. So let's deploy this, because then we can do a query here instead of a scan. We can specify the name of the index, so we can say we want to query this index. We can change this to be a key condition expression, and the expression values will be bean metadata. Value property projection must be an object. I think we might have to do it like this. Let's double check. Projection type. Let's try that again. I'm not sure if everyone's very quiet tonight, or if I'm talking into the void. I'm not sure I can see how many people are watching. If there are people out there, then it'd be really useful to know kind of what you are expecting and what you're wanting from these kind of streams, and then I can try and shape the next two sessions to include some things that are interesting to people or useful to people. I know obviously the idea of them is that they're fairly kind of raw and unedited and that sort of thing, but yeah, if there's particular things that people do want to see in them, whether they're watching it live, whether they're watching it on kind of catch up, please do drop a message in Discord or in the chat now if you're watching, and I will make sure that next week the session includes particular parts, unless you're going to ask me to spin up some massive server and create a massive bill, because in which case I can show you how to do it, but I'm going to want your credit card number for it. Cool, so that seems to deploy okay this time. So let's try this again with a different coffee. And this time, some different tasting notes. Cool. So that's added that one in. If we run this again, we can see, yeah, we've got that in there. Lovely. So what we can do next in that case is we can start to look at this querying for listing coffee beans. So we are cool. I'm glad it's been interesting so far, Colin. There is, in fact, before I forget, this book is like a DynamoDB Bible, essentially. It's not an official AWS one, but the guy that wrote it is part of their Hero program. So it's quite often they have promotions on it. So I think I paid about £60 or something for it rather than the full price. But it is really, really good, and is well worth the read if you want to kind of get into the real guts of DynamoDB. Equally, just playing around with it is always useful too. So we've got these three in here now. So let's get this list out. I'm kind of thinking here of, in our app we'll have a screen where we're showing the list of coffee beans, and then maybe we can click into a coffee bean and see all the different brews that we've made with that coffee bean and how things have changed over time. I'm just going to double check the syntax on this because that's caught me out before. Query, what have we got? Key conditions, key condition expression, and then expression attribute values. I was almost there. So now I've got this list here. So we'll have in here, you'll have a key called items, and what we'll get from this items list here is it will be an object that kind of maps to what we've got here. So we know that in the PK key in that object, we'll have the name of it, we'll have the roaster, the strength, tasting notes, all those things. So what we can do is we can probably we're going to do some transformation on this to convert it from the format we stored it in Dynamo to the format we want to return it in the API, in a similar way to we did on the way in with this. So let's how can we do this? So Python in particular, and I think most languages have it, have this map function. So in this map function, you can define a function to return or transform the value of something, and then the thing that you are iterating over. So we can iterate over this items list here, and then I'm going to create another function called something like transform coffee bean response. Yeah, that'll do. So what we've got with this function here is we'll get a bean in there, and my thinking is we can also use this method when we do the single get operation, because we're going to want to transform it again anyway. So we can get that there. So let's say from this we can return a name, which will be, actually let's call this item because it represents better that it's coming from DynamoDB. So we've got item, we've got strength, we've got the roaster, and we've got tasting notes. So what that will then do is this mapped items, let's call it transformed items, probably better, will run this function, over every item in this list, and then convert it back to a list afterwards, because the map function just returns a Python map iterator, which probably won't serialize nicely when it comes to returning this back to the client. So we've got this here, we're transforming it back to where we kind of need it to be. So what we can do now is really we can just return this as we kind of need to. So let's do this, let's call it coffee beans, and then let's return transformed items. And hopefully this will start to create a bit of a kind of a loop for us, where we can, obviously we know we can now put new beans in. This will then give us the ability to list beans out. And we're certainly on track tonight to be able to round off this whole kind of the coffee bean part of the REST API. Lovely. So that's now deployed as well. So we can, let's open up a new tab in Postman, and then let's just get the coffee bean here. Okay, that's always a good start. Let's have a look at the logs and see what happened. Actually, I know what it is straight away. So when you get access to a table to query, it doesn't automatically include the indexes on that table. So what you have to do is you have to explicitly allow access to query the indexes too. So let's indexes, you have to manually build up the ARN for them. Dynamodb, and then dump the region in there, dump my account number in there, and then I think it's index like that. And what I'm going to do is just to make this a little bit more consistent, I'm going to put that in like that instead. Right, that should do it. I'm also thinking before I deploy this that this coffee bean root here probably should be plural. So I'm just going to flick through and update them whilst I'm here. And then we also need to update it in here. I always find these sessions go so much quicker than they think they will. That might not be the same for people watching, but certainly from my side it feels like they fly by. I did make the joke to my work colleagues that rather than sit down with a glass of wine and watch the latest feature film on Netflix, they could spend that 2 hours listening to me ramble on about serverless instead, but not sure any of them have taken up the offer. Unless any of my Inawisdom colleagues are lurking out there and not telling me. So still getting an error, but it's not going to be because of what my immediate thought was. So let's have a look at this and see what we're getting. I see. I did the format wrong. It's table, then index after that. So I need to put that in the middle. Yeah. I think the one thing I heard last week that probably rings most true with AWS is that 99% of the time an error is relating to permissions. Yeah, more often than not it's because you haven't got access to something, which is quite reassuring, I think, because it means that you haven't just given everything full admin access, which is a huge no-no, but it's something that I do see an awful lot. Right, let's give it a go again. The nice thing about all of this is the feedback loop is quite short. So when you're making changes and then redeploying it, it isn't taking like 10 minutes every time to build and package it up and do all of that. Lovely. Cool. So they will come back as we expected. I'm just going to perhaps lowercase the start of that because it's going to bug me otherwise. Is the simple answer. Cool. So that's all looking pretty nice from a putting a new bean. In fact, we probably can just test that full workflow, can't we? So let's just call one that's unnatural. And it's strength 5, and it just tastes like coffee. So then if we run that one again, we'll get back, hopefully, here we are, our one that we just added. Cool, so I am going to commit this just so we know where we are. And it seems like a good point to mark in stone. There's probably bits we could add to this in terms of like, do we want to list them by kind of alphabetical order? Do we want to list them by sort of grouped by the roster in particular? But I think I might do that on the front end when we get there, because by default this will what will this sort by? This won't sort by anything in particular, unless you specify what you wanted to sort by. Normally it will use the partition key and then the sort key, but yeah, in this case it's not going to use either for this list one, but that's fine, not a problem. So let's do the get one next, I think. So just thinking about this, we've got this name here as our this name as our ID really for a particular bean. I'm wondering whether we need to my thinking, obviously, this is going to have spaces in and other characters that you might not want to put in a URL. So I'm thinking maybe we should, when we add a bean, we can use something like a UUID, for example. And this will make more sense in a moment. What is it? It's from UUID import UUID4. So if we did something like that and then said, okay, the name is then going to be our name, and name is our only required field we have as part of this. If two roasts had been called Colombian, so how it is at the moment, it would be covered by, no, it wouldn't be. So how it is at the moment, the partition key would cause an issue if two roasters had been called Colombian, because of the sort key, which is becoming our second part of our primary key, wouldn't be different. So that will also get around this kind of suggestion here will also get around that problem, because UUIDs are going to be unique anyway. So what I think we could do is we could do something like this, which will then only include include the name as a name attribute, and then the primary key as that. And then what we will do is that will also mean we'll need to change this, because we probably want to have like ID or something to be our primary key, and this would then be maybe name. And when it comes to getting a coffee bean, in my head the flow will always be, you can see a list of coffee beans, you click on your coffee bean, but by listing them you'll have the ID straight away. So I think that would be okay to pass the ID in. So let's roll with that. Let's just clean out Dynamodb and add some new beans in there so that we've got a better representation in our table. So for some reason my scroll wheel has stopped working. I don't know why that is. Strange. So yeah, let's go with that. We'll automatically generate an ID when we do it. We can do the same. We can use that same ID for grouping in the same thing here. So this, we can still use that when it comes to grouping for the sort keys and those brews that we're making. That's fine, I think. Yeah, cool, let's do that. Let's deploy that quickly, and then let's deploy that and then just put some more dummy data in there. I think getting the data model right is probably the hardest bit out of all of it. Obviously that doesn't really change whether you're building on NoSQL or kind of relational. You still have to think about your schema, but with NoSQL, I think it's harder once you've got an application in deployment to drastically change things. Not to say you can't, but it would be more challenging. Whereas my Postman gone. There we go. So let's send some data in. Let's kind of call this one fruity, and another one which is chocolatey. So we should then have our 3 in here still. I think we hit one of them before the Lambda had finished deploying, or finished updating. That's fine. So yeah, we've now got our 3 in here, and if we run our list again, we should hopefully get those 3 back. Cool, they've all got unique IDs this time. That's better. So then what we can do is, for this get coffee bean one, it's really straightforward, because we can we can look at this and we can just do it depends what we want to return actually, because you could look at this and say, do we want to return just the information about the coffee bean? Do we want to return the information about the coffee bean as well as all of the information about the brews we've made with that coffee? At the moment, I'm leaning towards just going for the coffee bean, because we can always make a second API call somewhere else on a page if you need to do that, and you can kind of limit load on the database by lazy loading things and all sorts. So I think we can just use this get item. So what we can do here is we can say I think it's key used for this. So when you get an item, you have to specify the primary key, or the partition key rather. Yes, Alex, you could do something like that, and just keep going and accessing related things that way. It'd also be an interesting thing to work on with like a GraphQL API, because then that would fit quite nicely, because you could then just as part of your query say, give me more information, and it would return kind of just what you need. And the sort key is going to be bean metadata. And I think that's all you have to specify. And then what you can do is you can check to see whether it got this item, depending on whether this item key is in the response. So if we say if the item isn't in the response, then we want to raise this not found error, because obviously it hasn't found it. And we can say bean ID was not found. And if we do find it, then we can return the transformed version of that data in the same way that we're transforming it for the list. So yeah, we can do it that way, I think. Let's deploy that piece of code and see what that does. You can kind of see once you kind of get the skeleton in place, it all kind of comes together pretty quickly. And yeah, once you sort of nail that data model and you know the access patterns that you're working with, yeah, it definitely makes life fairly quick to work with. So we've got that now. So in theory, what we can do is, if we duplicate this, let's rename this. I'm sure there's a way to rename. Perhaps not. Let's grab one of the IDs from here, and then let's get that particular bean, or not. What are we getting? My philosophy stands true of 99% of the time. It's permissions. I'm also going to add, while I'm here, the other two that we are going to need of the stuff that I'm hoping to finish off before we finish the session tonight, which will be deleting a bean and updating a bean. All of the same things you would think about with a relational database in terms of kind of what do you do with the coffee brews if you delete a bean. How would we handle that? Would we want to delete all the brews as well? Would we want to kind of soft delete the bean so the brews stay there and just get marked as kind of hidden or something? I haven't quite decided on that one yet, so we'll have to come back to that. Let's try now. Lovely. So we now get all of that from our API, and we can kind of see that the perfect, or the best thing about DynamoDB is it's just so quick. Pulling that data for that particular coffee bean is like, when you can see obviously it's changing a little bit, but we're in the kind of low hundreds of milliseconds, and then what I've done is with these functions I enabled Amazon X-Ray. So X-Ray is their kind of distributed tracing service for serverless things. So what we can then see is we can see on this map when it loads it, if we look at the last minute, that we've got this kind of function being called. The average execution time is 41 milliseconds, and the average response time from DynamoDB DynamoDB is in the last minute 13 milliseconds. But then you can also go through here and we can look at this and say, well, this took 23 milliseconds to handle this function. And you can kind of scroll down and you can look and see which things took the longest. And actually we can see that the DynamoDB part was 16 milliseconds to pull data out of the database, which is crazy. And yeah, it's brilliant to think that I haven't had to think about how much RAM do I need, how much storage, CPU, whatever. It's just throw the data in the database and go from there. Yes, there is a plan, Colin. I just haven't got around to it yet, but I will pop the link in Discord once it's up there. I'm not sure I've even created the repo yet, so it definitely isn't public, but it might not be private either. So let's just whip through these last couple of routes, shall we, for updating and deleting the coffee beans. So what we can do next is let's go for update, shall we? So following the kind of principles of REST API, we'll use put and then the bean ID. And I might just move this so it's a bit more sensibly located. So what we will do is we will we can use this, but change get item to put item. You have to specify your key as to what item you want to update. Then we can say the item is going to be, we're going to follow a similar model to be followed for the post one. So let's go for data to update. I'm going to grab this again. And just put that at the start. JSON. Data to add. It's going to be called data to update. We aren't going to need any of this stuff. And what I'm going to do is I'm going to do this instead. So we don't actually need the name in the request for this one, because if you update, oh, do we? No, I think we do. Change my mind. You don't want them to update it and update it without a new name, or even if it's the same name, then it's fine. But yeah, we want to make sure that the name is definitely in there. Put the item, and then if that's all worked, we can return a message to say bean ID being successfully updated. just going to lowercase these as well. Cool. Nice. And that needs to change to be update item. Let's hit deploy on that and try that one. And then let's go back to Postman, steal, say, turn that into a put, shall we? And then we want to send over, let's send over this data here. So let's change this from Brazil to, I don't know, Argentina. So we're actually going to change the name of the bean. So if we update that, we've obviously specified this in here. So we're hopefully going to see, not that. Unknown parameter and input item must be one of table name key. I remember now. So what we have to do instead is you have to write it in the kind of it's like a Dynamodb language, I suppose. So we'd say set name would be name and strength string and then what you do is similarly to how we did before. We say expression attribute values, and then we can put in here name would be JSON payload name. I'm going to copy and paste the rest of these and just update them. That can go. Cool, let's try again. I think that's how you do it. Let's have a look in here whilst that's loading. Table. Update item. Update expression. Yeah, that looks okay. Okay, so that's deployed. Let's run that, see what happens. Okay, still getting an error somewhere. I wonder if you just have to, okay, yeah, you don't need the ands, you just have to use commas, I think. Yeah. What you could do to make this a little bit more dynamic is you could build up this sort of on the fly. So you could say, actually, if you're only going to send in on your put request strength, then only put strength in here, and then only put strength in here, which could be quite a nice way of doing it. It's not too bad with this because only a few attributes, but if you had a really big item, then it might be something to think about. Okay, so that's deployed again. Let's try. Okay. Feeling attribute name is a reserved keyword. Okay. So Dynamodb is a little bit funny in that sometimes you get things like, well, name is one example, where it's reserved in expressions. So you can do a similar concept to this, and you actually do it like that to kind of force it through. Expression attribute names is what I think it was called. Expression attribute names, yeah. Providing this works pretty quickly, then I'll just do the delete one, and then we'll call it there, I think. Make the most of those 2 hours again. It's definitely getting time for dinner, I think. There we go. So we've now updated this bean, changed the name to Argentina. So hopefully if we do a get on that, we will find, let's just take this body out, name Argentina. Lovely. So the update one is now working. So the last one we will just squeeze in the last couple of minutes is the delete one, and it is basically going to be the same as the get one, except for one line, I think. So we'll change the method to be delete. I'll call it delete coffee bean. The operation will be delete item. Like I said, for now we're gonna for now we are going to not worry about what we'll do with the kind of child resources or child items of this bean. We'll worry about that when we get to the actual adding of brews in. But for now, I think we'll just worry about that. All I'm going to check before we hit the deploy button on that is how it handles the errors for deletions, because obviously you might not have you might find that it doesn't exist in the table. the documentation isn't the easiest thing to read. Table delete item. What happens if it doesn't exist? I think it'll be this one. So what we can do is we can import this client error, and then we can wrap it in a try catch. So if that is that, we'll raise a not found error. And if it does work, we can return a message just to say it has been successfully deleted. So let's just check one last bit. Error response. Oh, there we go. Good job I checked. Cool. Let's deploy that, and we will hope for the best. If it doesn't work, we'll if it's something obvious, then we'll fix it. But if it's not, we won't bother diving down the rabbit hole now. We will wait until next time. Okay, so that seems to have deployed. So let's hit delete. Let's first of all change this to one we know doesn't exist and see if the error handling is working. So the error handling isn't working, but it hasn't deleted it because there isn't one that's there. And when we run that one, which does exist, it's saying it's been successfully deleted. So if we get this list again, we should find there's only 2 in there now. Okay, so we know that it is deleting it. It's just, for some reason, perhaps not raising an error when it can't find it. That's fine. We can look into that next time. Yes, I think we've made some really good progress tonight. So we've now got sort of 99% of a RESTful API for the coffee beans part. So being able to update, post, delete, and get as well, and delete almost. I think we're in a really good place. So I think before we start looking at the second API, which will be for the actual coffee brews themselves, I think we will next time start looking at the front end and how we can build a really sort of simple React application with some authentication to test this against, or to make API calls against this backend, and go from there really, because I think it'd be good to start seeing some visual things. So yeah, thank you very much for again staying with me for 2 and a bit hours. I hope you all have a really good evening and see you again next week.